Okay, so we're going to start chapter 6. And chapter 6 is called like other topics in trigonometry. So chapter 6 is going to talk about solving non-right triangles. It's also going to talk about vectors. We will not do a chapter 6 test. We're going to learn basically section 6.1 and 6.2, the law of sines, the law of cosines, some area formulas that go along with it. And then we'll take a quiz over those, and then we'll do as much of vectors as we can and take a test over that. So we're going to do law of sines, law of cosines for the rest of this week and next week, and take a test next Thursday is when I have it planned for. And then when we come back from Christmas break, you'll have the same classes for 2 weeks, and so we'll talk about vectors for a little while, and then we'll do final review and take a final. So today we're doing the law of sines. So if you look at page 459 in your textbook, there is a proof of the law of sines, but just really fast to kind of tell you where the idea from the law of sines comes from, so you don't think that it's just something that was pulled out of the air. If you take any non-right triangle and you drop altitude down, so a height, so if I label this H, so if I say sine of A, so sine of angle A from this little right triangle right here, sine of this angle would be H over B, which means that the height of the triangle would be B times the sine of A. Well, if I go from this angle, I could say that sine of angle B is H over A. So we would get that the height of the triangle is A times sine of B. And then if you have the height equal to this and the height equal to this, then you can say those two things are equal to each other. And then if you just try to get your variables together, so if I put the sine B over here and the sine A over there with division, I would have B over sine of B is equal to A over sine of A. So you see how that kind of looks like this? You can do similar things and prove that B is equal to C and A is equal to C, so they all equal each other. So the law of sines uses this concept and says that the ratio of sine of an angle to the side opposite that angle is constant no matter which angle and side you choose. So the law of sines technically has two versions, which is just one is the reciprocal of the other. So I almost always write it like this. There is no reason for that other than that's where it was taught to me when I learned it, and so that's the one that I use. It doesn't matter which way you write it. Okay, so all we're going to do is jump in and solve some triangles. So remember when they tell you to solve a triangle, you're finding 6 pieces of information. We need to know all 3 sides and all 3 angles. All right, so anytime that I'm told to solve a triangle, because it helps with setting up your law of sines and because it helps with making sure that you got everything, you didn't forget anything, I usually set things up by saying side A equals, side B equals, side C equals, angle A equals, angle B equals, angle C equals. All right, so they told me this, they told me this, and they told me this. I'm going to have to find these. Now again, this is how I set things up to help myself. I don't need you to do this on every problem. I just think that it's helpful. All right, so first of all, the easiest thing is I can figure out the third angle because I know 2 of them. So if I do 180 minus those angles, I'm going to find the third angle in the triangle. So if I do 180 minus 105 minus 33, that will give me the last angle. So I got 42 when I did that in my calculator. All right, so now when you look at what you have, if you look at these, you're writing proportions basically. You're only going to use 2 at a time. So you can use those 2, you can use those 2, you can omit the middle and say that those 2 are equal. So if you look at what you have here, you have a matching pair, an angle and a side, and then here you have an angle so you can figure out the other side. So setting up the law of sines, we can say that I don't know A, but I know that that would go over sine of 33, and that's equal to 37.9 over sine of 105 degrees. All right, so now we're solving a proportion. So we're going to cross multiply and then divide. So we're going to say A times the sine of 105 degrees is equal to 37.9 times the sine of 33 degrees. And then we're going to have to divide by that sine of 105. So that you don't round multiple times in a problem, I wait until the very end to type it in. I also usually don't write this step down. I just know that I'm going to cross multiply and then divide by the extra guy. So I know that A is going to equal, multiply the diagonal where there's stuff there, divide by the one who's opposite what you're looking for. All right, so typing this in my calculator, I can figure out side A. So in my calculator, make sure that your mode is set in degrees, and then you're going to do 37.9 sine of 33, close your parentheses, divide by sine of 105. All right, so again, in the calculator, type it in, the numerator divided by the denominator, make sure that that parentheses gets put in there. And we get 21.3699, yada, yada, yada. So I'm going to call that 21.369, so 70. If they don't tell you you're supposed to go to 3 decimal places, since they only rounded to 1 decimal place here, you could round to just 1 decimal place. Again, I'm not going to be that picky as long as you round to the correct place if you're told, or you round correctly to wherever you round to if you're not told. If you're taking the AP exam next year for calculus, you're supposed to round to 3 decimal places. So keep that in mind. All right, so we're going to call this 21.4. All right, so we have the third side. And a lot of times students will say, ooh, I can use the Pythagorean theorem. Well, nobody told us that this was a right triangle, so we can't, oh, hey, look, I just read the directions. Round to the tenths. Good job. Okay, so I have to use the law of sines again. I cannot use the Pythagorean theorem because I do not have a right triangle. All right, so now I always go back to given information. So I'm going to use this as my matching pair, and I feel pretty confident that I got this right. So when I set it up, I'm going to say that 37.9 over sine of 105 is equal to C over sine of 42. All right, so what I was saying down here about not showing all of my work, I know that I'm trying to find C. These two that are diagonal from each other are going to multiply, and I divide by the one that's diagonal from what I'm looking for. All right, that's just skipping a step so you don't have to write as much. If you need to write every step, that's okay. If you can skip that step, that is okay. All right, so in our calculator, we have 37.9 sine of 42, close parentheses, divide by sine of 105. And we get 26.3 if I round to the tenths place. All right. So our next example is almost identical to that one. So we have 2 more examples. Let me think. I feel like I should have given you one where you're looking for an angle, so I don't really like my problems. Okay, so I want you to try number 2, and then I think I'm going to change number 3. So pause the video, try number 2. Okay, so I know these variables are different, but that's really okay. You have an L, an M, and I guess that's a little o. So we don't even know what the other letter would be, right? So you may have been confused when you tried this one, but let's see. We know that angle L is 29 degrees, not 290, 29. We know that little l is 22. We know angle M is 112 degrees. So we're going to have to find a little m. I'm going to assume that n is the next that we have to find. Alright, so let's see if we can figure out that other angle. Like whether you had a name for it or not, you should have been able to understand that you were going to subtract both of those from 180 to come up with what we need that other angle to be. So 180 minus 112 minus 29 is 39. Alright, so now setting up our law of sines, we're going to find side M first because this is the matching pair we were given. And then we'll find this. Then we'll go back and find n. Alright, so we can say 22 over sine of 29 is equal to m over sine of 112. So m is going to equal 22 sine of 112 divided by sine of 29. Alright, so in my calculator, I will type that. And I get, can you see that? Yeah, 42.1. Alright, so same process. We're going to say 22 over sine of 29 is equal to n over sine of 39. So n will equal 22 sine of 39 divided by sine of 29. So that's going to be the exact same thing except that this becomes 39. So we get 28.6. Alright, so number 3, I thought I was going to change it and then I decided not to change it, but I'd already messed up my paper. So number 3 is the same as the number 3 you probably just saw a minute ago, but anyway, moving on. Number 3 is going to be the same as 1 and 2. So again, if you want to pause and try this one and then see how you did, that would be a good plan. Alright, so we know A is 12. We do not know angle A. We do not know B. We know angle B is 65. We do not know side C, but we know angle C is 50. Alright, so why did I box that? So moving on. Okay, so for angle A, we simply have to subtract from 180. So 180 minus 65 minus 50 is 65. Alright, so if we work smarter, not harder, if these angles match, then these sides should match. So I know that this is 12. Alright, so then all I have to actually figure out is side C. So I can say that 12 over sine of 65 is equal to C over sine of 50. So C is equal to 12 sine 50 over sine 65, which means that C is equal to 10.1. Alright, which should make some sense because this angle is smaller, so that should be smaller than the other sides. Okay, so as long as I give you two angles and a side, It's one specific triangle, the law of sines will work, and everything's great. If I give you different information though, so I'm always going to give 3 pieces of information about the triangle, and you have to find the other 3. All right, so if I'm giving you 2 angles and a side in either one of these forms, you're going to use law of sines. There's one triangle. It's nice and simple. If I give you 2 sides and an angle, then you're either going to have to use the law of cosines, or the law of sines will work because you'll have a matching pair, but you don't have enough information at the beginning to even know if there's a triangle, which I will talk through in a few minutes. We will learn the law of cosines on Friday. So if I give you, just for reference, if I tell you 2 angles of a triangle, so this is fixed and this is fixed, and I tell you the side in between, then there's only so much that can happen, because if these are fixed, then this angle is really fixed too. So you are going to have one triangle. All right, if I give you 2 angles and a non-matching side, then you're going to be able to find that 3rd angle, and there's still just one triangle, because you know the 3 angles and you know one of the sides. Everything is nice and simple. If I give you 2 sides and the angle in between, then this part of the triangle is there. All you can do is connect it. And so again, there's one triangle. If I give you all 3 sides, there's only one triangle. So in these situations, there's always only one triangle. Okay? But you can't use the law of sines over here because you don't have matching pairs. I didn't tell you an angle and the side opposite. Okay? Now, this particular instance, the problem with that is if I tell you this side and this side, but I don't tell you the angle in between them, then you don't know what this angle is, right? So it's really more like I'm telling you this angle, and I'm telling you this side, and I'm telling you this side, but I don't know what this angle is. So there's some issues with that. So what's happening is when I give you this side, I could give you this side and it's so short that it won't ever reach. I could give you this side and it's like the perfect length that it forms a right triangle. It goes straight down and touches. Or I could give you this side that's a length where it comes down here and it can touch here, but it could also swing over here and touch. And then there's the option that I gave it to you that it's so long that it would never touch bottom. All right, so it's called the ambiguous case, and it's kind of ambiguous for y'all to think of. And I try to like draw pictures and use like little strings and swingy things. And hopefully it's going to make some sense. All right, so again, if I tell you an angle, so we know this and we know this side, but then I give you information about this side. Well, first of all, if you figure out the height right here, that's going to be, this is a right triangle because that's the height, which forms a right triangle. So this is opposite and hypotenuse, so we can say sine of A is equal to this. So we have that the height is B sine A. All right, so if I give you something that's shorter than this, there are a couple of options if I'm shorter than that. I can be this long, which is exactly B sine A, which would only give me one triangle. Okay, or I could be shorter than that. Let me see if I can find like a little piece of, here we go, string. I was not prepared. I forgot that string was helpful. Okay, so if I give you an amount for this side. That is the exact height of that side. So when I swing that around, it's not going to hit bottom anywhere but that one place. Okay, if I give you an amount that's shorter than that height, so I'm still shorter than side A, and I'm shorter than that height, then what's going to happen when I swing it around is it will never touch bottom. So there's not going to be a triangle. If I give you an amount that is shorter than side A, but longer than the height, then it could make a triangle swung out here, or I could swing it in here and make a triangle. So I would end up with two different triangles that I could make. All right, if I give you something that is longer than side A, then it's never going to touch over here, but it could kick way out here and make a triangle. All right, so that's the best I can do on a video to show that, sorry. So what we're going to do is make two little cases to keep in our notes to refer to help us while we're learning. Okay, hopefully by next Thursday when it's time to take this test, you will have this like solidified and remember it. Okay, so when I say compare A to B sine A, that's the height of the triangle like we were just talking about. All right, so if the angle that I give you is less than 90 degrees, okay, so remember, ambiguous case is when you're given side angle. All right, that's the only time you have to use these cards, these like cases. I used to put them on note cards for kids, that's why I call them cards. So if we have an acute angle, then I look at side A and side B, the two sides that I've been given. If A is less than B, then I may have no triangle, I may have one triangle, I may have two triangles. Okay? For no triangle, that's if A is shorter than the height of the triangle. One triangle is if A is exactly the same as the height of the triangle. Two triangles is if A is more than the height of the triangle. All right? If A is not less than B, then it has to be greater than or equal to B. And that's only going to cause one triangle because it can only make a triangle kicked out here. All right, case 2 is if we have an obtuse angle. If our angle is greater than 90 or equal to 90. All right, so in that case, we are going to just compare A to B. We don't need to know the height of the triangle. If we have an obtuse triangle, if side A is shorter than side B, then it has no prayer of ever touching bottom. If side A is longer than side B, then it will be able to reach and make a triangle. All right, so all we're going to do today with the ambiguous case is practice figuring out how many triangles do I have. All right, so keep in mind though, as we do this, that we are trying to, first of all, just worry, is it ambiguous at all? Okay, so when you look at what you're given, I have angle, side, side. If I give you angle, side, side, which spells a bad word, right? If I take side, side, angle, and I turn it around and call it angle, side, side, that makes a bad word. If what I give you makes a bad word, it's ambiguous. It's the ones you don't like. Okay, it's a pain in that bad word. All right, so this is ambiguous, which means you have to use your case 1, case 2. So the first choice that we make is my angle bigger than 90 or less than 90? So which case am I talking about, case 1 or case 2? So we're going to be talking about case 1. So look at your case 1 card, or your chart for case 1. All right, if we now look at these, is A greater than B or less than B? And it looks like A is greater than B. So first of all, we said A is less than 90. So now we compare A to B, and we can say A is greater than B. And since A is greater than B, we're looking at this situation, which means we have one triangle. All right, next we have angle side side. Our angle is less than 90. So it's angle side side, we know it's ambiguous. We know that angle A is less than 90. So now we compare A to B. We have A is less than B. Since A is less than B, we have to figure out what B sine A is and compare that to A. So we know A is 18. If we do B sine of angle A, so in our calculator we're going to do 25 sine of 63. 25 sine of 63, and we get 22.3. All right, so if we compare these, 18 is less than 22.3, so A is less than the height. So going back to our cases, we have decided that our angle is less than 90. Side A is less than side B. So now we're looking at 18 is less than 22, so A is less than B sine A, which means we have no triangle. So number 2 would be 0 triangle, so you could write no triangle. All right, where's my next page? Okay, so number 3. All right, here we have side-side angle. All right, so we still have ambiguous. When we look at our angle, we say that that is more than 90 degrees. So we have case 2. For case 2, all we have to look at for case 2, because we're greater than 90, is compare A to B. So if I compare A to B, so compare 10 to 8, we know that 10 is more than 8. So A is greater than B, tells me I have one triangle. All right, how about you pause the video and try 4 through 7 and see if you can figure those out for yourself, and then unpause and see how you did. All right, so again, angle side side, so we know it's ambiguous. We have A is less than 90, so we're looking at case 1. We have A is less than B, so we've got to compare A to B sine A, compare A to B sine A. So we know A is 40, 50 sine of 51, so B sine of A gives me 38.9. If A is greater than B sine A, you have 2 triangles. All right, number 5. Again, it's ambiguous because it's angle side side. We have angle A is greater than 90, so that says look at case 2. So compare A to B, so 8 compared to 15, A is less than B, so we have no triangle. All right, number 6, you have angle side side. All right, this one's a little more confusing because I didn't give you A's and B's. Okay, so we have A. So here's the thing, when you're trying to figure it out, if it makes it easier, whatever angle I gave you always needs to be what you're considering A, which means this would have to be considered B, and this would be considered A, because these match. So if this is angle A, this is side A, if you want to rename them to make things look a little easier, more like your cards. All right, so our angle is less than 90, so we have case 1. Comparing A to B, we have 12 compared to 23, so A is less than B, which means we have to compare A to B sine A. All right, so again, A is 12, B sine A, so 23 sine of 34 is going to give me basically 16. Sorry, I couldn't get words out. So this is less than, so that means that we have no triangle again. All right, so here, number 7, you have 2 angles. So if I have angle, side, So I have two angles and a matching pair. That's the easiest way to think about that. If I have two angles and a matching pair, then it is a law of sines problem, and there can only be one triangle because I gave you two angles. If you are given two angles, it's always one triangle. It's only if they only give you one angle that there could be a problem. All right, so your assignment is solving the simple ones, and then tell me how many triangles there are for some that may or may not be ambiguous. So keep in mind that they may not all be ambiguous. Pay attention to what you're given. All right, please let me know if you have questions, and we will do more of the ambiguous case stuff tomorrow. You are not supposed to 100% understand it right now.